in hunting for a shadow. I sacrificed my peace of mind, a matter of real substance.
Isaac Newton came here to Cambridge as a young student in the early 1660s. It was here that all his genuinely creative science, philosophy, and religious ideas were formed. Light meant everything to Isaac Newton. He thought of it as an almost divine principle. He thought that the world had been made by a single, wise, omnipotent, clever, mathematical God. A God who, to be frank, rather resembled Isaac Newton.
There is a being who made all things, who has all things in his power, and who is therefore to be feared.
And so in investigating light and colour, what Newton thought he was doing was peering deep into the mysteries of God's creation.
And it was in 1664, aged just 21, that Newton first began to study light and vision. Newton's reputation, then as now, was as an intensely solitary man. Of few friends, violent enmities, and obsessive energy. Newton's first thoughts about light and colour were prompted by an extraordinary degree of self-examination. It's as though he turned his attention inwards, into his own mind. He would stare at the sun for hours and then shut himself in a dark room, and by will alone he'd try to summon up the image of the sun.
And then his self-experiments got much more dramatic. He wanted to see if there was a difference between the images we see because of pressure, because of something pushing on our eye, and the images we see when we simply think or dream.
So what he did was to take a wooden needle and put it between his eyeball and the bone and push.
Don't try this at home. If you do this, Newton found that you get coloured circles appearing just above the focus of your eye. And the coloured circles followed the order of the colours of the rainbow. Newton was so focused, so concentrated on the most minute details of phenomena like that, even at the risk of his own eyesight, that he was driven to see if there was a way of making the optical phenomena that appear inside our own eyes, in our own minds, appear in the outside world, so that others could see them. With prisms and lenses and mirrors, Newton reckoned you could do just that.
Newton had one aim: to show the world that Descartes' mechanical theories about light and colour were utter nonsense.
Now, a certain gentleman has suggested that colours are mechanical, and that it is the prism that changes the white light into colors. But this theory is not only insufficient, but unintelligible.
Newton would design a series of experiments on whose replicability the whole status of his new theory of light depended. Newton made a very tiny hole in the window shutters, allowing a beam of sunlight to fall on the opposite wall. And then he intercepted the sunbeam with a prism. He positioned the prism very, very carefully so that the angle at which the sunlight hit the prism was the same as the angle at which it left.
Finally, after weeks of effort, he made a breakthrough. What Newton had done was to make an artificial rainbow. He saw red, orange, yellow, green, blue, indigo, and violet.
And he invented a word for the sun's image, coloured as it was. This word was spectrum.
For the first time, Newton had precisely measured the colours in a ray of sunlight. Centuries later, knowledge of the spectrum would extend to X-rays and radio waves, ultraviolet and infrared. It would even reveal what the stars themselves are made of. Yet for Newton, this was only the starting point. The spectrum was the key weapon in his holy war over the true nature of divine light.
What I proposed was not to explain the properties of light by hypotheses,